Welcome back. In the last video, I explained integration as a reverse process of differentiation, and I explained it as if you have my pen as a function and if you destroy the pen, what you did is differentiation. The process of repairing the pen to have the pen back is known as integration. And I told you to keep it at the back of your mind that if you don't know how to differentiate, if you don't know how to integrate, don't differentiate. Meaning if you don't know how to repair, don't destroy. Today, I'm going to continue from where we stop. So, and I'm going to take you through standard integrals. So that is the common integration you have to know. And since integration is a reverse process of differentiation, so far that you know some of the standard derivative, then we just take their inverses. Okay, now let us take it one by one. If you have your y, an integral of y with respect to x. So first one is when I have x raised power n, don't forget integral of x raised power n is x raised power n plus 1 divided by n plus 1 plus c. You understand? So another one is when you have constant. Integral of constant is you just add L to it. So because of abuse of the constant, let me use A here, then I'm going to have AS. Recall that in differentiation, when you have 5s, derivative of 5s is what? Is 5. Since integration is reverse process of differentiation, then when you say integral of A with respect to s, what you are saying is what are you going to differentiate to give you A? You know it is AS. It means integral of A is what? Is AS. You understand? Likewise, what did we differentiate that gave us 1 over s? You know it is ln x. Then integral of 1 over s is ln s plus c. You understand? Integral of 1 over s is ln s plus c. What did we differentiate? What did we differentiate that give us e raised power s? It's also e raised power s. Then integral of e raised power s is also h. It's also e raised power s. But don't forget your constant of integration. Recall we have something of this in differentiation too. What did we differentiate that gave us what? What did we differentiate that gave us cos x? You know that is sin s. It means integral of cos s is sin s. Don't forget when we differentiated sin s, we had what? When we differentiated cos x, you know we have minus sign. It means integral of sin s is what? Minus cos s plus c. It is reverse process. When you differentiate sign, you are going to get cos, but when you integrate sign, you are going to get minus cos. You understand now? When you differentiate cos, you are going to get minus sign, and when you integrate cos, you are going to get sin s. So, but in general, e raised power as, remember when you differentiate e raised power as, I said it's going to give you a e raised power as, but if you integrate it, you are going to put it here 1 over a e raised power as plus c. I'm going to explain that in the next video, how we obtain this. Likewise, sin as. So you are not going to put it as, you are not going to put the derivative of this as what? As product. But it's going to be what? As quotient. So that's going to give you 1 over a cos as plus c. I'm going to explain why we have that. Likewise, cos as, that is going to be what? 1 over what? 1 over a sin as. I hope you understand the difference now. So when you have e raised by as and you are differentiating it, don't stress yourself, that is a e raised by as. But when you have the integral of e raised by as, it means what you differentiated here, which is a, you are going to put it at the denominator. That's 1 over a e raised by as. In essence, e raised by 1000 s will give me what? 1 over 1000 e raised by 1000 s. Likewise, integral of cos 5s is going to be 1 over 5 sin 5s. It is as simple as this. It is as simple as this. Who can remind me what other things we did? Okay. So don't forget your sin s. The same thing as what? Integral of sin s is cos s. That is what did you differentiate that gave you what? This. So likewise no, sin AS is going to give me cos AS plus C. Also don't forget your cos AS is also going to be sin AS. Oh sorry, I forgot tan. Sec square S. Integral of sec square S is tan S, because when you differentiate tan you are going to get what? You are going to get sec square. It is just inverse of, I mean reverse process of what? Reverse process of derivative. Reverse process of derivative. Also in general, when you have sec square AS, don't stress yourself, that will give you what? 1 over A tan AS plus what? Plus C. Don't forget, what did we differentiate that gave us 1 divided by square root of 1 minus S square? You know it is arc sine S, right? It means integral of this is what? Arc sine X. What of this do you recall? You know that is arc cos X. Also 1 divided by 1 plus S squared, that is what? That is arc tan X. So that is arc tan S plus C. You notice that is just what? The reverse process of each other. So please, if I were you, I will still go back to my standard derivative and know some of these things. So if you know standard derivative, then it is very easy for you to know the standard integral. Just take their what? The reverse process. So if you understand this, please don't forget to like and share. If you've not subscribed to my channel, don't forget to do so. I will meet you in the next video. Thank you.